In the previous parts, we saw the simple essentials for ancient civilization and the technical development that drove the wonders of the Renaissance and the 17th and 18th centuries. In this part, we will look at the Industrial Revolution. It is often said that the start of the Industrial Revolution was the steam engine. It is true that heat engines, the first ones using steam, later ones using hot gases, produce a source of portable muscle. The internal combustion engine is the standard. The gas is heated by burning inside the cylinder. The principle is simple. A piston in a cylinder is pushed by heated gas. If the volume is constant, the pressure is related to the temperature by P equals mT. In computer form, that is, pressure equals m star temperature. The problem is getting the gas to stay behind the piston. Any tiny gap between the piston and cylinder will leak gas and rob the engine of power. Getting the piston to fit the cylinder precisely requires machining. Machining, therefore, is the true source of the Industrial Revolution. In a machine tool, a sharp, hard tool is moved in a straight line against a workpiece. In a lathe, the work rotates and the tool moves in a straight line. The machine has a flat plane with a sliding carriage, a rotating shaft, and accurate screws to move the carriages. Setting this machine up in different ways can produce a staggering variety of shapes. Cylinders, spheres, planes, gears, and screws being the main ones needed. To understand the change machine tools produced, consider a clock gear. An old clockmaker produced a crude gear by hand in a day. A gear machine produces a near-perfect gear in a second. Of all the devices made by machine tools, one contributed more to stabilizing society than any other. Land disputes are usually the strongest source of friction between two people or groups. In a society founded on spiritual satisfaction, such disputes would not arise, of course. No one would own the land. Most civilizations have fallen short of this goal. In a non-spiritual society, the most important way to ensure stability is to have good agreements on who owns what land. This is the role of the surveyor, an individual trusted by both parties to decide where boundaries are. To earn this trust, the surveyor must have extremely accurate equipment. Surveying is done by two techniques, one easy, one laborious. The easy one is to measure angles, using similar triangle formulas to find lengths. The hard one is to measure lengths by marching over the land. By combining a precision machined protractor and telescope with a microscope to read the protractor, really precise angle measurements are possible. This is a theodolite. It has a telescope, a microscope, a horizontal protractor, a vertical protractor, and a fine micrometer to measure angles to 1 second of arc. Little to argue about there.